of sine and cosine for trigonometry. So we had this person who was told that if he rode up the hill for a mile, he could see the top of this 100-foot building. And we were wondering which angle we needed. We could do the sine right here and get this little skinny angle, or we could do the cosine and get this much wider angle. But either way, how do you get the angle by itself? How do you get rid of sine? Well, there's this thing called inverse sine and inverse cosine. And the way it works is, if you look at your calculator, right above sine, you should have sine inverse. And you put the fraction in, so it's sine inverse of the fraction y over r, so 100 over 5,280, and it will give you your angle. So I'm going to do that right now. Okay, so you might be wondering why I don't just do the decimal. 100 divided by 5280 repeats and repeats and repeats. So it's easier just to put the fraction in. So I'm looking at the cosine right here. So cosine inverse is right above cosine button. So second cosine gives me the cosine inverse of 100 divided by 5280, close the parenthesis, enter. Now 1.55 doesn't seem like a very big angle, does it? I mean, until you remember that we are in radian mode. So this is 1.55 radians. If I change it to, degree, and I want to do this to show you something that was really cool. Okay, so quit. I'm going to pull up the same function, so second entry, because that's what I typed in before. Enter. So 88.9 degrees from this angle. That is almost a 90-degree angle right here. So let's see what happens right here. We do sine inverse. So second sine inverse of 100 divided by 5280. Enter. 1.85, so about 1.09 degrees. Okay, so we're talking itty bitty. So you don't have a very steep angle at all. So if you're going to go a mile before you see the top of the building. And the reason I was showing you this is because I wanted you to see that 88.91 plus 1.09. Okay, they're going to add up to be 90 degrees. So the sine of the far angle and the cosine of the close angle are very, very, very related. Alright, now the story that I promised you. When I was still living at home, a little carnival came to town and I said, I'd like to ride the Ferris wheel. So let's say I was in this seat, and ahead of me was a man and a woman, and we got to about this point right here, and they started screaming, and I couldn't figure out what was going on, and so we came around, and I got up to this point, and the man was yelling, "Stop, stop!" And I looked, and the woman wasn't in the seat anymore. And so they stopped the Ferris wheel, and the guy running it climbed up the spokes. They had lights attached here, so it could glow in the dark. Here's a star, wee! and it was catching on the foot of that seat they were sitting on, and so as they went, it tipped him over forward, and the woman fell out the first time they went around, and the man managed to hang on, but when he got over around the second time, and the worker raised his foot over the light, brought us all down to the end of the Ferris wheel, kicked us all off, and shut the whole Ferris wheel down. So, my question is, how far did she fall? Well, we're talking trig here. A right triangle in a circle. And I want you to remember that when we start talking trig, we come from the horizontal and we go up. When you're on a Ferris wheel, you start at the bottom. So we're going to have to work with this idea. So this is about where she fell. Close to the top, she fell down. So it was about, I was trying to say, not quite half of the rotation, so about 6/13 of the rotation. The wheel was 2 feet above the ground so that we could, sit on the seat. And let's say the radius was 12 feet. So obviously she didn't get killed. In fact, I saw the couple walking away later. So we know already from just this much information, if she had fallen just halfway, that would have been 14 feet right there, because radius is 12 and the height above the ground was 2. So we're just going to concentrate on this part of the circle. I'm going to pause because these earphones are driving me nuts. Okay, PowerPoint works better with the closed caption if there's a microphone, but man, was that driving my ear crazy. Okay, so we can think in terms of radians, or we can think in terms of degrees. Get a different answer if you're not careful. So let's just look at this part of the circle. We already know the 14 feet. So let's figure out how many radians it went around. That will tell us this angle right here, and we'll go ahead and call it theta. So she ran around 12 pi 13ths of a circle. And this corner piece down here is pi fourths. So we're going to have to subtract that to get our theta, our angle. We end up with 35 pi divided by 52, because 13 times 4 is 52. And again, I personally recommend leaving it as a fraction rather than trying to change it to a decimal number, because you can't get enough decimals to be very accurate, as accurate as you'd like to be. So we know that this length is 12 because that was the radius, and our angle is 35 pi divided by 52, and we're left with y. So this is the angle, or the side away from the angle, so that's the sine. So the sine function will be y divided by 2, and then for theta we just stick in the 35 divided by pi. Let me go back. Okay, so you can see it. This is what theta will be. Now I wanted to stop here and then go to the degree part because it's pretty similar. I went ahead and changed it to a decimal because when you're doing rotations it's 360 degrees. So 61.51, or was it 15? Let's see what I wrote. No, it was 15. Sorry about that. And we know that the bottom part is 90 degrees, so we're going to have to subtract. And it will give us 76.15 degrees. But the sine function looks exactly the same as when we did it before. I'm trying to go backwards. There we go. See, this piece looks the same. The difference is, what mode are you in? Are you doing radians or are you doing degrees? Okay, let's do radians right here. Okay, so y will equal 12 times the sine of theta. Let me see. Let me change to radian mode. Okay. Quit. I'm trying to think. What's the next one? So 12 times the sine of 35 pi. About this time you're thinking, why isn't it easier to just do degrees? It's about the same. Okay, so this will give us how far, the distance she fell in that first part, and then we add on the 14 feet she fell from the halfway point. So altogether it looks like she fell about 24.3 feet. So yes, it's survivable. Man, are you going to be shaken up. Now, if we come to the part where we do degrees, so right here we've got 76.1. The method looks the same. It's going to be 12 times the sine of the angle. But we have to make sure we're in degrees instead of radians. So, quit. And then, let's see. So I'm just going to pull this up so you can see it's the same piece. Oh, I had an extra parenthesis. I didn't even realize it. Okay, but this is wrong. Okay, so I'm going to have to delete. Delete. So 76.15. Close parenthesis. So you see the difference? This is a radian angle and this is a degree angle. And because I had rounding, you can see that it's not as accurate. Plus 14, enter. So that gives about an extra 1.5 feet just by the rounding. The radius probably wasn't that much because she was able to walk away from this. But Ferris wheels are fair game for finals, midterms, tests, questions on the street, who wants to be a millionaire. So hopefully this helps with your sine and cosine homework.